The National Electrical Code, or NEC, does not explicitly exclude batteries, but batteries fall under general electrical safety requirements outlined in Article 500. Open terminals must be insulated to prevent electrical contact and hazards. A disconnect switch or another suitable means is required to safely disconnect cables without creating a spark in a hazardous area. Extra hard usage flexible cord, or XHUF, can be used to extend cables outside the hazardous area to the disconnect switch, as long as it complies with the requirements for flexible cord in Article 501. 501.10. The 5 requirement for a grounding conductor applies to equipment and wiring within a hazardous area. Since the battery will be temporarily brought into the area, it may not be practical to provide a permanent grounding conductor. The second sentence of 501.25 states that insulation, other than that provided by the enclosure, may be used to protect against hazardous conditions, such as where the enclosure does not provide sufficient protection. This means that additional insulation can be used to supplement the protection provided by the enclosure. Consider the use of XHUF cord to extend the battery cables outside the Class 1 Division 2 area. Install explosion-proof switches with interlocks to allow connection and disconnection without sparking. Provide additional insulation around the open terminals of the battery to protect against hazardous conditions. Consider using a temporarily grounded bonding jumper to provide grounding for the battery while it is in the hazardous area. Ensure that all electrical connections are made securely and properly torqued. Monitor the battery and its connections regularly for any damage or potential hazards. Firstly, ensure compliance with NEC Article 500, which provides the general requirements for electrical equipment and wiring in hazardous locations. This article establishes the classification of hazardous locations based on the properties of the flammable vapors, liquids, or dusts that may be present. Secondly, pay close attention to Article 501, which specifically addresses Class 1 locations, where flammable gases or vapors may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further divided into Divisions 1 and 2, depending on the likelihood of the presence of flammable materials. Thirdly, determine the specific classification of the hazardous area where the battery will be located. This classification will dictate the types of equipment and wiring methods that are permitted in that area. Fourthly, open terminals must be insulated to prevent accidental contact and potential ignition of flammable materials. Use listed and labeled terminal covers or insulating boots to protect exposed terminals. Fifthly, a disconnect switch or other approved means must be provided to safely disconnect the battery from the electrical circuit without creating a spark. Explosion-proof switches are typically required in Class 1 Division 1 locations, while intrinsically safe or non-incendive switches may be permitted in Class 1 Division 2 locations. Sixthly, XHUF cord can be used to extend the battery cables outside the hazardous area to the disconnect switch, provided it meets the requirements of Article 501 for flexible cords. The cord must be suitable for the environment in which it will be used, and it must be properly supported and protected from physical damage. Seventhly, the 501.10. The 5 requirement for a grounding conductor applies to equipment and wiring within a hazardous area. This grounding conductor is intended to provide a low impedance path for fault current, which can help to prevent the buildup of static electricity and reduce the risk of ignition. Eighthly, since the battery will be temporarily brought into the hazardous area, it may not be practical to provide a permanent grounding conductor. In this case, consider using a temporary grounding conductor that is connected to a nearby grounded metal structure. Ninthly, the second sentence of 501.25 clarifies that additional insulation can be used to supplement the protection provided by the enclosure. This is particularly important in hazardous locations, where even a small spark can have catastrophic consequences. Tenthly, consider using a bonding jumper to provide grounding for the battery while it is in the hazardous area. This bonding jumper should be sized according to the requirements of Article 250 and should be securely connected to a grounded metal structure. 11thly, ensure that all electrical connections are made securely and properly torqued. Loose or corroded connections can create hot spots that can ignite flammable materials. 12thly, monitor the battery and its connections regularly for any damage or potential hazards. Look for signs of corrosion, loose connections, or damaged insulation. Replace any damaged components immediately. 13thly, ensure that all equipment used in the hazardous area is listed and labeled for the specific location. This includes batteries, switches, enclosures, and wiring. 14thly, follow the manufacturer's instructions for installation, operation, and maintenance of all equipment. 15thly, provide adequate ventilation to prevent the buildup of flammable gases or vapors. 16thly, implement a comprehensive safety program that includes regular training for personnel working in hazardous locations. 17thly, conduct a hazard assessment to identify potential hazards and develop appropriate control measures. 18thly, develop and implement emergency procedures to address potential incidents, such as fires or explosions. 19thly, maintain accurate records of all inspections, maintenance, and repairs. 20thly, consult with a qualified electrical engineer or other expert in hazardous locations to ensure compliance with all applicable codes and standards. 21st, NEC Article 100 defines approved as acceptable to the authority having jurisdiction. For electrical installations, the authority having jurisdiction is typically a local or regional electrical inspector or building official. This individual or agency is responsible for enforcing the provisions of the NEC and other applicable codes and standards. 22nd, the NEC defines a hazardous location as an area where fire or explosion hazards may exist due to the presence of flammable gases, vapors, liquids, dusts, or fibers. These locations are classified according to the type and degree of hazard present. 23rd, Article 500 of the NEC provides the general requirements for electrical equipment and wiring in hazardous locations. This article establishes the classification of hazardous locations and specifies the types of equipment and wiring methods that are permitted in each location. 24th, Article 501 specifically addresses Class 1 locations, where flammable gases or vapors may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further divided into Divisions 1 and 2, depending on the likelihood of the presence of flammable materials. 25th, Class 1 Division 1 locations are those in which flammable gases or vapors are present continuously, intermittently, or periodically under normal operating conditions. Examples of Class 1 Division 1 locations include areas around petroleum refineries, chemical plants, and natural gas processing facilities. 26th, Class 1 Division 2 locations are those in which flammable gases or vapors are not normally present in the air in quantities sufficient to produce explosive or ignitable mixtures. However, flammable materials may be present under abnormal conditions, such as during equipment failure or accidental release. 27. Batteries used in hazardous locations must be specifically designed and approved for use in those locations. These batteries typically have explosion-proof enclosures and other safety features to prevent ignition of flammable materials. 28. Explosion-proof equipment is designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. This type of equipment is typically used in Class 1 Division 1 locations. 29. Intrinsically safe equipment is designed to operate at low voltage and current levels so that it cannot produce a spark or hot surface that could ignite flammable materials. This type of equipment is often used in Class 1 Division 2 locations. 30th, non-incentive equipment is designed to not cause ignition under normal operating conditions. This type of equipment is also often used in Class 1 Division 2 locations. 31st, sealing fittings are used to prevent the passage of flammable gases, vapors, or liquids through conduit systems. These fittings are typically required at the boundaries of hazardous locations. 32nd, grounding and bonding are essential for electrical safety in hazardous locations. Grounding provides a path for fault current to flow back to the source, which helps to protect personnel from electric shock. Bonding connects all metal parts of the electrical system together, which helps to prevent the buildup of static electricity and reduce the risk of ignition. 33rd. Wiring methods used in hazardous locations must be suitable for the specific location and the type of equipment being used. Common wiring methods include rigid metal conduit, intermediate metal conduit, and cable with a metallic sheath. 34th. Flexible cords used in hazardous locations must be extra hard usage type and must be approved for use in those locations. These cords are typically used to connect portable equipment to the electrical system. 35th. Lighting fixtures used in hazardous locations must be explosion-proof or intrinsically safe. These fixtures are designed to prevent ignition of flammable materials in the event of a lamp failure. 36. Control equipment used in hazardous locations, such as switches, relays, and motor starters, must be explosion-proof or intrinsically safe. This equipment is designed to prevent ignition of flammable materials in the event of a malfunction. 37. Heating equipment used in hazardous locations must be designed to prevent ignition of flammable materials. This equipment typically has temperature-limiting controls and other safety features. 38. Ventilation is essential for maintaining a safe environment in hazardous locations. Ventilation systems are designed to remove flammable gases, vapors, or dust from the air and replace them with fresh air. 39. Personnel working in hazardous locations must be properly trained on the hazards associated with those locations and the safety procedures that must be followed. 40th. Regular inspections and maintenance are essential for ensuring the safety of electrical equipment in hazardous locations. Inspections should be conducted to identify any potential hazards, such as damaged equipment, loose connections, or inadequate ventilation. 41st. Emergency procedures should be developed and implemented to address potential incidents, such as fires or explosions. These procedures should include evacuation plans, fire suppression techniques, and first aid measures. 42nd. All electrical work in hazardous locations must be performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. 43rd. Any modifications or repairs to electrical equipment in hazardous locations must be performed in accordance with the manufacturer's instructions and the requirements of the NEC. 44th. All electrical equipment in hazardous locations must be properly labeled to indicate its suitability for use in those locations. 45th. A permit may be required for electrical work in hazardous locations. Check with the local authority having jurisdiction to determine whether a permit is required. 46th. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. 47th. In addition to the NEC, there may be other applicable codes and standards that must be followed, such as those issued by the Occupational Safety and Health Administration, or OSHA, and the National Fire Protection Association, or NFPA.